Jó napot! A nevem Ovidu. Actually, I don't speak Hungarian. I will only speak in English. So I need my internet connection for my presentation. So, thank you for having me here. Unfortunately, I do not speak English, but I'm going to present you our vision regarding the flexibility of manufacturing. Right, so in our vision, the robots should be movable from one station to another. Now, this ratio of how much time it requires for the robot movement versus the robot working is pretty low. So for this reason, we really believe that the robot wheels should be actually modular, but I don't know what. So basically, I represent Oviso Robotics. I'm the CTO of Oviso Robotics, and I'm going to show you our flexible mobile solution. Now, this is our product and solution called Ovi. Our solution is mobile, multi-purpose, flexible, and very rapid. Actually, it is the fastest commissionable robot on the market. Now, I know it sounds very crazy, but I'm going to tell you something, which is not a joke. If you find on the market any faster commissionable solution for any robot, I mean universal robots, I'll give you all my robots for free to you, okay? And this is no joke. So, about mobility. We have designed a mobile skid. So our mobile skid can be transported, like you see here, manually with a forklift or with AGVs or MRIs. This is for the flexibility of the robot to be brought from one station to another. So let's imagine a workshop with some more CNCs when we need the robot to be movable from one CNC to another, but we want it with less than 5 minutes, with no tools, and the most important is that the client would like to pay nothing to the third-party integrator. So we want the client to be able to move the robot himself, okay? Now, the question is, how can we decommission and recommission a big robot, like a UR10 or UR16, in less than 5 minutes, and the robot should also work, I mean the full commissioning, okay? So this is our answer. Actually, this is a map of technical features that we have developed, and I'm going to take it one to another to explain you how it works. So the first thing, the first biggest challenge, it was the calibration. So let's assume that this would be a working station, and I would like to bring my robot over here, right? And I would like to make a pick and place from here to here. Now, if I would take the robot out and bring it back and put it a little bit in another position, I would have to retouch up all the points. Now, for this pick and place with 4 points, it would be easy, but let's imagine like 10 or 100 points that we have to reteach. With our solution, the robot is calibrating and all the points are automatically self-calculated. It is nothing rocket science, actually. We use the robot encoders. Right, so we have this calibration tool, which we call the point zero, because it's actually the 0 point according to all the points are recalculated. So in this way, no matter if I place my robot like here or 180 degrees, as long as the robot reaches the point in the robot's work volume, all the points are going to be recalculated. I believe I have to wait for this video to be finished. Yeah, and we have the only approach with calibrating in the Universal Robot Plus, UR Plus ecosystem, and we are really proud about this. Now, the second thing is the magic connector. It's actually nothing magic. It's just for the marketing reasons called magic connector. It's actually the first and only plug connector which brings all the utilities to the robot, like the air, the internet, the power, the GPIOs. They are all over there. Why we want it this way? because we want, with no specialist, no tools, so we can plug the whole utilities to the robot. So in this case, the client himself can do it properly, what normally some more engineers would do, like a proper electrician, he would come with the EPLAN data sheet, and he would take all the IOs, nice socks, all the IOs and put them each by each, right? And then should come the electrician with the power and so on. Now, over here, we have this connector. I believe we have English subtitles over here. And what is the most important thing? It is not swappable, so you cannot put it wrong. Once you plug it in, you just bring all the utilities to the robot. Another very interesting thing is that we also have a software solution which is actually called the station manager, by which the robot is filling in what station we have plugged the robot. And according to that station, he will automatically load the installation file, the URP program and everything, asking the user to mount a specific tool. Right. Now, the next thing that I'm going to talk about is with the tools, because according to each different station, the robot might need a different tool. And I would like to tell you that this was our start of developing. Actually, it was a research between me personally and Universal Robots. I asked them, what are the reasons when the robot is malfunctioning, and why are your robots breaking? And of course, they said our robots, they do not break. But I told them, okay, even Mercedes-Benz sometimes breaks, so let's make a research. And we did this research with lots of Universal Robot clients. And the answer was this. The robot is malfunctioning when the operator is setting not proper data of the tool. So if the tool, it weighs 2.5 kilos and I will only put 2 kilos, the robot might work, but it would tremble and the gears would crash faster. So this is our tool changer. It's a combination between Shunk, I see over there a Shunk thing, and our software, which is automatically recognizing which tool. Moreover, in all our tools that we develop, we have a digital support, and in each tool, we have the data of the tool. So with no databases and no updates, once the human operator is plugging the tool, which takes like 3 seconds, then the robot retrieves the data from the tool and sets it in the installation file. So this is my colleague Rasmus. Right, so that was the tool changer. Next, we have the built-in sensors. It's very interesting that in most of the robotic cells, we have lots of sensors that are common. So we said, why not take all those sensors and put them, all of them, in the metallic skid, so the client will not pay those sensors for all the stations, only where the robot is running. So here it's a small demo with the already built-in sensors that we have. That's Romanian. Right, so there are, let's say, the 80%, the critical mass of the sensors that we need in all the robotic cells already built in our frame. Also a pneumatic valve, because Universal Robot has no air control. For safety reasons, we have this IFM sensor, which is monitoring the presence of the teach pendant, because in some cases we need the operator to operate the teach pendant in a safe position. So we want the operator to stay in a specific location. Right. Now, this thing, what I showed you, is just the tip of the iceberg, because this is our core business. It's this movable skid which allows the client to decommission and recommission the robot by himself with no tools, no paying for the third-party integrator, in less than 5 minutes. And the robot, it's already starting in 5 minutes, right? Now, why I'm saying that what I showed you, it's only the tip of the iceberg, because we have also developed lots of stations in which you can bring your robot. Now, these are optionals, and you can buy it as an option. This is our philosophy, that complete solutions should have lots of different stations and some robots movable. But it's very important to understand why we have not included wheels in our skid. So is this reason? The cost of batteries, navigation system, LiDARs, wheels, it's pretty expensive. So we believe that, let's say, for example, you have 5 robots, you only need 1 pair of wheels. The robots should not move like more than 5% out of the working time, right? So in the next slides, I will show you some stations, so you can understand what a station means in our approach. Of course, we have actually lots of stations, but I only brought in these slides some stations. So this is the case Erector station. I believe Bruno also said something, but I would like to, because I don't really understand Hungarian, I don't know what you said, okay? I would like to tell them my point of view. Now, this is a station in which the robot can be plugged and turned on in 5 minutes. This video has 2 minutes, and you will see that 2.5 minutes actually. It is not fast forward, and my colleague will also make the parameters of the box. Now, when I say turnkey solution, I mean we should have a station, and the client should not program. This means that for this station, the robot is going to make the erection of the boxes or the cases only by filling in our URCAP the box size, the X, Y, Z, and then the robot will automatically change the whole trajectory and everything. Also, the whole trajectory, now, that was the calibration. So by that thing, the robot will now know where it is according to the station, or in respect with the station. Now the robot over here is saying, okay, Lucian, he's my colleague, I'm in the case Erector station, so I need that specific tool. Of course, the operator can say no, but if the robot is asking for that tool, we install that tool. Now the robot is pretty happy. It knows that in this station it needs to case erect. It has the tool for case erecting. Now my colleague over there in the URCAP is only putting the box data. Also, for this package, we have this dropping point, which is teachable, because after a box is erected, we want to be placed somewhere. But in order to have it very flexible, maybe some clients, they have a conveyor, maybe they have a slope, a gravitational slope, and in order for our clients to have flexible management of the layout, we are having this teachable dropping point. Now in this case, the robot is starting to erect the cases for this size. If there would be some other sizes, the operator only should fill the data. That's all he has to do. So that's a complete solution. Okay? Now the next package I'm going to show you, it's pretty related. It's a palletizing package, but we have actually packages in many other industries. Okay. So this is the palletizing. Now in this palletizing package, we also offer a pattern maker. It's a software which should run on Windows or Linux. Yeah, for each video we show how you easily plug and you make that calibration of the position of the robot. But this software that we also give it for free when you opt for the palletizing unit, it's actually a pattern maker, which is actually returning 2 files. There is one PDF file as a report with the total weight, total height, everything about that pattern of the palletizing. And also there is one file which is not human readable. The operator just has to have that file on a stick, put it on the robot, and then hit play, no matter what the box sizes are, and no matter what the pattern looks like. And yeah, this is our software. It now looks better. This is the PDF report, and this is the stick that you only have to bring it to your robot. In this video, for the demo purposes, we have showed lots and lots of, now this is the calibration, lots of patterns. Maybe some of them are just for the demo. Yeah, so this is the calibration. Now the robot knows where it is in respect with the station. And I have to tell you some more about our palletizing hardware, right? Because that conveyor that you see over there, there are 3 different conveyors on the same frame, which means they run different speeds and they can count the boxes even they come stacked by one another. I'm pretty confident that we have the only solution on the market that the robot is asking the conveyor to bring 1 or 2 boxes according to the pattern. So in order to achieve a very good productivity, in the universal robots environment, there are lots of palletizers, and everyone is bringing the robot to the maximum speed. Our vision is that if you want higher productivity, the robot must be able to pick 1 box and 2 boxes according to the pattern. So in that case, it's not about the speeds, it's about the intelligence of the robot. Right, of course, the sensors are over there monitoring the pallets. The robot is stopping. It will then ask you whether you want to continue or not. And we have this so-called continuous palletizing, which is the robot will automatically palletize on left or right sides, no matter where you just have to bring the pallet. You don't have to tell the robot, please palletize on that side. Right? Now, we also have some custom packages, like we have worked a lot with London development office from UiPath, and we have the only solution on the market that the universal robots are communicating with UiPath technology. And the robots are, for the first time, moved by UiPath artificial intelligence. So we are pretty proud to announce that we are the first company on the market which we have this solution by which you do not have to program your robot. Not even a single point, because the UiPath artificial intelligence is doing that. Moreover, with UiPath technology, we can make this bridge of SAP or whatever MES the client have, because that's UiPath job, right? So we have developed our engineers together with their engineers. What I'm going to show you over here is going to be a demo for Toyota Japan, which they were impressed because they were already using UiPath. I would like to ask you how many of you knows about UiPath? You know. You know, good. Good. Right, so that's in our lab, live with the Japanese team. And over here we just demonstrate the palletization and then the calibration, and then they are using the UiPath orchestrator to program the robot. We actually made a bridge software as a UR cup, which you just have to install it on your robot, and the UiPath orchestrator is going to move the robot. But I'll fast forward this one. It's 3 minutes. Yeah, right. So over here you can see the UiPath orchestrator, which is actually building the blocks for the robot movements. Now some very small examples. We actually have, I believe, tens of packages, but I don't want to waste your time. So this is a 5-axis milling robot with our calibration. So basically in this package, the point 0, which is our calibration method, is only telling which is the 0 of the G-code that the robot is running. And in this video, my colleague over here, Bogdan, actually wanted to make a 3D violin, changing the tools and running some more G-codes. I'm just going to play it on fast forward, not to waste your precious time, because I strongly believe in communication and I would like to talk with you, and maybe you have questions better than this video. So there is the 3D violin. Okay. Yeah, we have some happy clients that we are not very interested. Now, this is a very interesting client. This is a client making 2 million euros out of bending metal wire. That's the only thing that he's doing, bending metal wire. But he's having these machines for bending, but he's having lots of machines. And he couldn't afford more robots, like a robot for each machine. But he wanted to take advantage of the robot for all the machines, and he was not happy to pay the third-party integrator to decommission and recommission, because the biggest nightmare of any client is the factory shutdown. So they are very happy when they hear that in 5 minutes they decommission and recommission with their employees, with no specialists, no tools. There is some machine tending with sheet metal bending. Okay. How do I close this? I believe that's all for me. Now, I would like to have some questions for you, and thanks God Bruno is here to help me with translation, because I do not know. I only know Yonopot, I know Nem tudom, and O Novem Ovidu. So, please come with questions. Yes, please.
What you show looks for like genius, yes?
Thanks.
And I usually encounter environment health safety officers in companies who are not so cool as you are, and how you deal with the local safety rules. Because these actually the solutions that I would like to see, but at the end of the story, sometimes it is covered with 50,000 euros of sensors and everything, because the local rules allow only that. And how you get through these barriers. And
yeah, that is a very good question. Thank you for the question. The point is that normally in a robotic cell we would have a CE mark, right? Made with a risk assessment, and then there is the declaration of conformity. Now, what we do is actually we have different CE marks on the mobile robot and on the station. So basically, when you run our solution, you have 2 CE marks. Why is that? Because if we only put 1 CE mark on the whole robotic cell, and then you move the robot, the CE mark is not available anymore, because you have to do the risk assessment once more. Now, in this case, we have a risk assessment on the mobile skid of the robot, which is static, right? But no matter how you put this mobile robot, we know that according to that calibration, the robot is going to move the same. And then is the next CE mark of the station, which means this is what we had to do. It was not our desire to have 2 CE marks on each robotic cells, but apparently this is the only way that we can assure the risk assessment and that it's working.
Más kérdés esetleg? Akkor én is elárulhatom, hogy románul csak ennyit tudok, hogy Buna Ziva.
Ziva.
Ziva. Jó napot jelenti, és képzeljétek el, én adtam elő a román parlamentben, mert ott tartanak ipari kiállításokat, robotos kiállításokat, és a román parlamentben sikerült nekem előadnom egy robotos témakört, és a végén én azzal zártam, hogy ígyunk akkor a magyar-román barátságra. Én már megittam a Pertút Oviduban, de én erre bátorítalak titeket is.
Now, we've been traveling from Romania here just to meet you guys and to get in touch with you. So we would be very happy to get to our table and have our brochures, our visit cards, and then get in touch and to know each other and to have this correspondence on email. Thank you.